personal side of stories. All right, anyway. Your homework, here are the answers. So like I said, well, actually, before I let you, like I said, we're going to be sprinkling in review amongst our regular chapter 9 stuff that we're doing. I'm not going to spend a huge amount of time going over these, but like Megan said, she had one that she just had no idea, or two. We'll go over those ones, but we're not going to go over all 20 every time we have one of these. But if there was a few that you're like, did we even learn this? And you don't even remember even briefly, I will talk about them. So here's the answers. Again, you skipped 1, 2, and 3. The answer to 4 was 3, 5, 1. You skipped 6, 7, 8, and 9. And then the answer to 10 was 1, 11, 2, 13, 2, no, 12, 2, 13, 3, 14, 1, 15, 2, 16, 4, 17, 3, 18, 4, 19, 3, 24. And before we go over any, as long as I'm here, your homework is going to be 21 through 40. No, you're skipping 36 and 37. I didn't write it down here, but I just crossed them off. So skip 36 and 37. If again, you could write your answers on the answer sheet, that will make both of our lives tomorrow slightly easier. Now, what ones, I'm going to use two. What one do you want to go over? 17. So why doesn't everybody go to 17? So even if you got it right, it is definitely good for you to go over it. Oh, this is the earthquake stuff. Did you do this before or after lab? Oh, darn, I was hoping lab would have cleared it up for you. So I definitely need a reference table where, there it is. So this is a question you would have needed your reference table for. So it tells us the arrival time of the first earthquake was, so it tells us the P wave got there at 10, 11, 20. The epicenter was 8,000 kilometers away. They want to know what is the approximate arrival time of the first P wave or the first S wave. So this one was a tricky one. This wasn't as straightforward as what we did in lab, but you work with what they give you. So they told us, this is when they told us the earthquake was 8,000 kilometers away. So we start there. If the earthquake was 8,000 kilometers away, I know I can do this, that the difference between the P and the S is that much space. So I mark that off. That's how far, that's the time between when the first P wave gets there and when the first S wave gets there. If you bring that down, you can see that that's a difference of, it looks like 9.5 minutes. So how can we use this information of 9.5 minutes? Well, they told us the first P wave gets there at 10, 11, 20. And now we know the difference between them is 9 minutes and 30 seconds. So that means 9 minutes and 30 seconds after the P wave gets there, the S wave gets there. So all you have to do is add those two numbers. So 10, 11, 20, and 9 minutes, 30 seconds. So 10, 20, 50, and hopefully that is one of the answers. 10, 20, 40. So they must have thought it was a little bit more like 9:20. I said 9:30, but yes. And hopefully 3 was the answer. Yeah, it was. Okay, good. I know what I'm doing. So you just have to use what they give you and what you know how to do. I will admit that was probably one of the tough ones that most people will probably get that type of question wrong because it does take what we know to a whole other level. And Megan, you had another one? Or 19. 19, which tectonic plate is best represented by the diagram? So in the diagram, we have an ocean plate coming together with a continental plate. So you just had to match this up with our reference table. We want convergent with an ocean plate and a continental. So you go check out the answers. The first answer was the Nausicaa and Pacific plate. They're pulling apart, so that's not it. So the Scotia plate, which is right there, and the South American plate, that's a transform, so they're not coming together. The Juan del Fuego, that's right there. And North America, that is a plate with the boxes, and that is a converging plate boundary. So that could be it. Double check the other one. Antarctica and the Indian Australia. That's right here. Those are pulling apart. So the only one that was a convergent plate boundary. How did I know this was a convergent plate boundary, by the way? Because there's a trench there. And what's happening is the plate is coming together and doing that. But again, trenches are always associated with convergent boundaries. So the Juan de Fuego and North American plate is the answer. Anybody else have any that you're just like, I have no idea what they're talking about? Fourteen is just from the last chapter. So I think probably the first problem was this one was a long sentence and it just went on and on and on and on. And the answers were long and they just went on and on and on. And you probably lost interest and didn't stay focused. Not just you, most people who got it wrong, probably that's what happened. So a city located on the coast of North America has warmer winters and cooler summers than a city at the same elevation and latitude located near the center of North America. Which statement explains the difference between the climates of the two cities? So what was the big kicker in that sentence? Where are these two cities? They're both in North America, and what's the difference between the two of them? Okay, but it keeps going. Where is that city that has warmer winters and cooler summers located? On the coast. And the other one is inland. So which one of these has to do with things being on the coast and temperatures being affected? So it's saying which statement could explain the difference between the climates? Ocean surface changes temperature more slowly than land surface. That could definitely be it. Warm, moist air rises when it meets cold. That has nothing to do with it. Wind speeds have nothing to do with it. And water has a lower specific heat. Now that could be true, except for we know that water has a higher specific heat. So the reason they have different ones is because they are located on the water and the surface water temperature changes differently or more slowly. Any more? All right, so if you have any more, let me know. We can go over them again at another time. If you don't want to do it in front of the whole class, that's fine. We're going with, again, your homework 21 through 40, skipping just 36 and 37. In the meantime, we got to grab our packets, and on yesterday, we were working on page 14 of your packet that said the solar system. You know what, before we do that, I think we need to fix something in our packet. So everybody on page, why don't we start on page 14? And I just want to do a little bit of editing. So you were on page 14. Get ready, we're going to do some flipping. Do you notice that the next page has no page number where it says force of gravity? It's blank on that page. Why don't you put a 15 there? We're going to go through and number some pages because there's a whole bunch that are missing. So the page after 14 is 15. What? Okay, then turn the page to where it says planet velocities. There again is no page number, that's 16. 17 is labeled. If you guys can't get the hint, we're just labeling. So 17 is labeled. 18, it looks like that page number got cut off, so that's 18. Then flip over to 19, which at the bottom is this question 16. This is gonna be page 19. Keep going, just keep flipping. 20 is labeled. 21 with this, all these circle shapes. And the back is not labeled. This is where it's gonna start getting weird, where it says ellipses of the moon. That's page 22. Yes, then turn the page. So everybody here where it says solar eclipse, that's page 22. But tides also says 22. Please cross that off and make it say 23. And then the next page has 2 page numbers. That's page 24. So cross off where it says 23 and make it 24. I don't know. I'm not perfect, Cynthia, just better than most. Then the next one, 25, looks like it got cut off. And now just keep going in order, but they did get cut off, so 25. Some of them are labeled, some of them are not. Just keep going. Don't stop. When you get to 31, it's labeled and it should be labeled correctly. It is labeled correctly, so if you aren't there, you did something wrong. And it should end on page 34. I'll give you guys a second to catch up. If anybody is not sure what page something is, let me know. Did you end on page 34? Okay, we're going to do, and if you remember yesterday, I mentioned we're going to be doing some jumping around. And in fact, because of my experience with your class yesterday, I'm actually going to do some jumping that I didn't even plan to do. Does everybody got the pages numbered? We're going to go to page 28 then. I know I said 14. But I want to start on page 28. It's called Our Solar System. So if you guys remember yesterday, I started talking about our solar system. And when I asked you guys about our solar system, it became clear to me you weren't quite sure what was in our solar system. You guys remember this? This was you guys, right? That we weren't sure what was in the solar system? Yeah. Okay, so this is what I want to clear up. Oh, I should have mentioned this. Grab your reference table, open it up to page 15, please. Reference table 15, packet 28. 28. 28 in the packet, 15 in your reference table. Bottom of page 15. So yesterday I asked you off the top of your heads what was in our solar system. Some of you knew some things, but not all the things. And then some of you added extra. So here is good news. None of you have to memorize what's in the solar system because the solar system is all listed here on page 15 of our reference table. So these, again, titled solar system data. So this is all the things that are in our solar system. So you can see it starts with the sun, and then it lists the planets in order, by the way. So from the closest to the sun to the farthest away. It does then throw in Earth's moon. So hint, by the way, the Earth's moon is not a planet, but they put it here just because sometimes we're curious about the moon. Then it tells you how far they are from the sun. So you can see their sun is 0 kilometers from the sun. But then Mercury is 59.7, but notice the units, guys, that's millions of miles from the sun. It's pretty far, but nothing compared to Neptune, which is 4,498.3 million miles from the sun. Now, they did put a note on the Earth one that it is 149.6 million miles from the sun, but then they put that it is 0.386 million miles from Earth. So in case you're wondering how far away the moon is, 0.386 million miles from the sun, from the Earth, sorry. So they do have them in nice, neat order, closest to farthest. Then they tell you the period of revolution. Hey guys, from our notes the past 2 days, what is revolution? All right, we're gonna all have to get up and demonstrate this. Everybody up, push your chairs in. Actually, those of you at the table, push your chairs out. The rest of you push them in. Holy cow, that's noisy. I should never ask you to do that again. Right now, I would like you guys all to revolve, please. No, all right, we got a few of you guys. Revolving means to go around. How about we just revolve around our desks? Careful, don't rotate. I'm just asking you to revolve. Revolve, and those of you at the tables, revolve around your desk or your chairs, because you can't revolve. It's difficult. All right, you guys are revolving. You guys had to modify your over here. Sorry. You revolved, guys. Revolving means going around. So it sounds like some of you are still confused because a bunch of you started to rotate and a bunch of you didn't move. So if I asked you to rotate, in fact, I'm going to rotate. What a bunch of ballerinas you are. Now remember, ballerinas rotate on their toes. It's really called releve, but many of you don't know that. Make sure you push down with your big toes when you releve. Yep, so ballerinas, they rotate on their toes. Row-toe, that's all I got for you. Hopefully that helps. Picture me rotating. Come on, everybody rotate like a cute little ballerina. Only Mr. D and I. Thanks, Mr. D, I appreciate it. So sit down. So hopefully you won't get those two confused. Revolution means going around, rotating means spinning. Okay. Do we need to write that on here? I think we should. So we're gonna have to write at the bottom on your reference table. Everybody pick up your pen. Goes around sun, right underneath the revolution one. Goes around the sun. And what should we write underneath the rotation one? Holy cow, we just did this. Spin. Now, which one of these, rotation or revolution, represents a day? Which one takes a day? Spinning. So here's what I want to do at the top. See where it says rotation? Actually, let's do this the other way. See where it says revolution? Put your finger right, put your pencil right above the word period of revolution. And I want you to write year. We'll go through it. And then over period of rotation, I want you to write day. So a year is how long it takes to revolve. A day is how long it takes to rotate. Now I want to look through this. So let's talk about the year first. For Earth, the year is 365.26. We already talked about that. Close to 365 for a year. Take a look at all the other times. Notice anything weird about some of those numbers. 88 days. For 1 year to happen on Mercury, it only takes 88 days. So instead of having a birthday every 365 days, you'd have a birthday every 88 days. Yes, you guys would be old. Now we'd be older, but you'd be old too. Now let's talk about, but wait, if you look down even further, Neptune, take a look at that. 164.8 years. And those are, by the way, our Earth years. So they're comparing it to Earth years. So if you wanted to have a birthday, you'd have to wait 164.8 Earth years to have a birthday. So you guys would be really young, but you'd probably die before your first birthday. Yeah. Now let's talk about days. Again, how long does a day take on Earth? We know this one. 24-ish hours, 23 hours, 56 minutes, and 4 seconds. But let's look at some others. Read down those. Notice anything weird there? So Neptune, if we were looking at the day, a day on Neptune is 16 hours. A day on Uranus and Saturn and Jupiter, they're all in hours. They're all way smaller than ours. Mercury, it takes 59 days, Earth days, to go through one day on Mercury. Wait, check out Venus. Anything weird happening on Venus? Yeah, 243 days for one day to go by. But there's something else weird about Venus. Do you see it, Tori? You look like you might see it. What do you see, Tori? There's only 224.7 days per year. What? Their day is longer than their year.
How does that work?
I don't know. I don't live there, dude. But how it works is that it takes longer for them to spin than it takes them to go around the sun. So what would it be like living there? I don't know. But good news is you can't live there. You die if you went there. So we'll never find out. Just wanted to point that out. So it's a little weird there. This whole eccentricity of the orbit, we're going to start that tomorrow. So we'll come back to that. Diameter, you guys know what a diameter of a circle is, right? Yeah. It's how fat it is all the way across the whole circle. So they're saying how fat is the circle at the equator? That's why it says equatorial diameter. And this is in millions of kilometers. The sun is 1,392,000,000 miles wide. Compare that to Earth, because I can't think of numbers like that. Earth is 12,756. Sun's a lot bigger than the Earth. So is Mercury, 142,984 kilometers. Again, Earth is only 12,000 something. Isn't that what I said? I didn't mean to say Mercury, you silly goose. I meant to say Jupiter. All right, Mercury is much, much smaller. A lot. Mercury is almost a third of the size of us. Now mass, and this is given not in like pounds or even millions of pounds, it's given in Earths. So notice Earth weighs 1 Earth, but the sun weighs 333,000 Earths. So if you had a balance, to kind of balance out, you'd need 333 just to make one sun. 333,000 to make one sun. So Mercury then is super, super small compared to the mass of Earth, 0.06. Jupiter, pretty big, 317.83 Earths to make one. And then finally, the density is the last column. Now, what do you guys remember is the density of water? What's the density of water? What is it? Not 0.01. By the way, guys, it is on the front page of your reference table. The density of water is 1. So it has a density of 1. Well, let me not compare it to like something that's much more dense. Dense has a density of 1. It's not that dense. Compare it to like the density of the whole Earth. The Earth is has a density of 5.5. So that's 5 times more dense. Quite a bit. But let's keep looking. What's the density of Saturn? 0.7. Yeah, so what would happen if we put Saturn in a bucket of water? It would float because it's mostly made out of gas. So I just wanted to point this out that they were all here. They put them in order for you so you don't have to remember what order they go in, all that good stuff. So that's there. So next time I ask you what's the solar system is made out of, or what it lives in the solar system, you don't have to guess. It's all right there. So on that note, let's go back to page 28, which starts with our solar system, and just get a few vocab words out of the way so that you will now know what's in our solar system. You do? What is it? It is a rock. What's the most famous meteor there is? Come on, dude. It's the one on Joe Dirt. You've never watched Joe Dirt.
Like 5 years ago.
Yeah. Don't you have it memorized?
It's like a nuke or something.
No. Come on. Somebody tell them what the meteor was on Joe Dirt. And if you guys don't know, I have lost faith in all of humanity. What is it, Hayden? It's space doo-doo is what he calls it, I believe.
Said it was like a nuke.
Oh, I didn't hear the full of crap part. Well, it wasn't a nuke. It was just dropped from an airplane and it was a pile of dump. Yes, a pile of doo-doo, I believe is what he calls it.
Well, he threatened to hit it like it was a bomb. I remember that.
He also ate French fries and dipped his ketchup, or ate the French fries and dipped the ketchup was right on the thing. And if you guys don't remember this, and those of you who have no idea what I'm talking about, your homework is to go home and watch Joe Dirt.
I have no idea what you're talking about. It's not worth watching.
No, you know what's not worth watching? Joe Dirt 2. Ain't good. It's bad. It's really stupid. But Joe Dirt 1 is good. You should watch it. I don't know. It's actually a really bad movie, but if you haven't watched it, I can't believe you. No, I haven't. I hate Wayne's World. My husband likes it. Mr. D, what are your thoughts? I don't. Yeah, I never found it humorous. No. Haven't. Yeah, I know. Yeah. Yeah. Yeah, no, I've actually never watched it. Anyway, so terrestrial planets. They are the planets that are rocky and Earth-like. They're the ones made out of the same stuff Earth is made out of, silicate rocks. We learned about those rocks at the beginning of the school year. And the examples of them are Mercury, Venus, Earth, and Mars. And if you match that up to your reference table, those are the first 4 planets, the ones closest to the sun. The opposite of a terrestrial planet is what's called a Jovian planet. These are the gas giants. They are Jupiter-like, very low density. So the 4 outer planets, Jupiter, Saturn, Uranus, and Neptune. Dude, I can't say Uranus in front of a bunch of 10th graders. Because, yeah, you're all just as mature as everybody else. Yeah. I can't even say it in front of my husband. Who am I kidding? I guarantee you somewhere in that test booklet, there is a question that asks you a question about terrestrial or Jovian planets. It's in there somewhere because it's a question they just like to ask. Again, terrestrial are the first four. They're the rocky ones. Terrestrial, if you forgot, means Earth-like or from Earth. We talked about that with E.T., another movie some of us have seen and some have not. Again, I've never seen the whole thing. So E.T. means extraterrestrial, that's alien-like. Terrestrial means Earth-like. All right, we good with that? What? Just Ted? No, not that. Yeah, not that Ted. The next one's an asteroid belt. It is located between Mars and Jupiter. It's composed of thousands of asteroids. So it is basically just a spot between Mars, I did it again. Mars and Jupiter that has a whole bunch of broken up rocks.
You ever seen Fall?
No, dude, do some homework and stop watching movies.
It's a funny movie. It's about an alien.
Just do some homework instead. All right, so the asteroid belt, again, is just this spot located in between these two planets. Lots and lots and lots and lots of broken up rocks there. Then we have what's a meteor. It's a streak of light that occurs when a meteoroid enters Earth's atmosphere. It's often called a shooting star. A meteor shower is when there's lots of these. So a shooting star, like I wish upon a shooting star, you're not actually wishing upon a star, wishing upon a streak of light, which is most likely a rock or other space debris that enters our atmosphere, gets really heated up because it's hitting our atmosphere and it makes a streak of light again, or it's a pile of poop from Joe Dirt. Hayden, you've ever seen Joe Dirt? You like it, right? It reminds me of my husband. No, but he drove a stupid old car like this guy liked. No, Bob. So similar. Mrs. Saley, are you peeking in? Okie doke. I actually made it just for you this time.
I know. It wasn't.
Then of course, you better know what a meteorite is. This is one that actually hits Earth. So I actually should rephrase. Joe Dirt's thing was a meteorite. Not a meteor. It was a meteor when it was in the sky, a meteorite when it hit the ground. Little ones hit often. It depends on like where we are in our orbit around the Earth. No, orbit around the sun. I know it's been a rough day. This is nothing compared to last period. This is like a great lesson. So if we are close to going through the asteroid belt or if it's passing near us, there could be more. And the last thing that I wanted to include, no, comet is a huge dirty ice ball. So comets are actually made of frozen, typically water and other elements. They go around the sun just like the planets, just like the meteoroid, asteroid belt. Their orbits are way different than the rest of the planets. And the thing is, when they get close to the sun, their dirty ice starts to melt and it leaves behind a tail. fun fact, when I was your age, the comet Hale-Bopp went through, it comes through like, it was like every 1,000 something years or even more than that, I don't know. But because of this rare occurrence, a cult known as Heaven's Gate thought they were here to save them and take them to their alien planet or whatever, and decided that that was their savior. And to get on it, they just had to kill themselves, and they committed mass suicide to go hop on Hale-Bopp. You ever heard the phrase drinking the Kool-Aid?
Yeah.
So have you ever heard that phrase? They've been drinking the Kool-Aid. It means like you just agree, you drink the Kool-Aid and you agree with whatever they say. Well, it came from them drinking poisoned Kool-Aid to kill themselves. It's not, it's real, and it stuck out because I was your age when it happened. So I was young and vulnerable. I don't. Guys, don't forget to do your homework. It is 21 through 40. 40, skip questions 36 and 37. I thought